Swayam Prabha. Digital India. Educated India.
Today I am going to discuss kinematics of a particle. Now, what is a kinematics? Kinematics is the area of mechanics concerned with the study of motion of particles and rigid bodies without consideration of what has caused the motion. When we take into consideration the factors causing the motion, the area of study is called dynamics. Now, just see this slider crank mechanism. Now, here when I am moving the crank, then this slider is moving. If I know that what is the speed of the slider I need to have, then for that how much RPM crank should rotate. If this type of question is posed to us, then we must know the kinematics. See here, if I am moving the crank, the slider is moving. Okay. So, if I am rotating it by, let us say, 3 RPM, then what is the slider speed? Or conversely, if I am moving the slider at certain speed, what will be the crank speed? Such type of questions are answered by kinematics. In kinematics, we are not concerned with the forces, we are concerned with the displacement, velocity and acceleration. All of you are familiar with these terms. Now, quite often we only deal with the kinematics. For example, if I want to design this mechanism, and let us say this is just a toy mechanism, then probably we need not carry out extensive force analysis, but nevertheless we have to do kinematic analysis in order to find out the relation between the motion of various rings. Similarly, suppose you are going from Pan Bazaar to Paltan Bazaar and you are going in a cycle rickshaw, you are concerned that at what speed the rickshaw moves. Or if you are going by train from Delhi to Bombay, you must know that what is the speed of the train. In these type of questions you take interest. Generally, when we design certain machines, then only we pay into attention into the forces. So, therefore, engineer is usually concerned with the forces, whereas the kinematics has got much wider application. Another point is that when we take into account the forces and we then we must know the motion also. Therefore, dynamics encompasses kinematics also. So, dynamics encompasses kinematics because Newton's law says force is equal to mass into acceleration. Now, if you want to calculate the force, you must know the acceleration also. So, therefore, study of kinematics is very important. Now, why we are talking about kinematics of a particle? Now, in this, if we see that kinematics, this one, kinematics is the okay. In kinematics of a particle, what is a particle? Particle is the concept that which is having a mass but not having any size. A rigid body can be considered as a combination of a particle. Therefore, the concepts learned for a particle can be helpful in understanding the kinematics of a rigid body also. Moreover, sometimes what happens that bodies can be treated as a particle. For example, I play this animation for you. Let me just play this call. So, this is here in this okay. This is a bit tight, that here this I am not able to, yeah, this is again that problem. See, it is another thing I observed, 1 minute, that you can continue kinematics is the area. One slide he missed, that particle I said now that you have to take the velocity and acceleration of a, see, there was one slide in which definition of a particle was given, but that slide he missed. But anyway, I have spoken it, but one slide he missed. See that I said that that in one kinematics is the area of this one. After that, second point was there, that slide he missed. When this type of thing happens, then I become nervous, and this is the thing, that this is why that I am not able to do. See, he has missed one, and then here I was not able to move this one. See, this one, now I am doing. See, it is very difficult. Now it is, see, now I am able to do. Okay, so I am continuing from here. Okay, fine. Okay, let me play the animation here. Okay, this is the animation, and this is okay, this call. Why this pen sometimes it comes, sometimes it doesn't come. See, it is sometimes it is coming, sometimes it is not coming. What? No, animation. I need, sometimes it comes, sometimes it doesn't come. एक तुमने हटा भी दिया वो स्लाइड, देखो पार्टिकल वाला, पार्टिकल है जो साइज एंड दिस थिंग, ये हटाया था, तो उसको बाद मैं बोला कि इसको बराबर, बट वो पार्टिकल का हटा भी दिया तुमने, इंस्टेड तुमने ब्लैंक स्लाइड इसमें डाल दी. ये जो है हो गया, है ना. काइनेमेटिक्स ऑफ ए पार्टिकल, तो पार्टिकल की डिफिनीशन थी, है ना. तो दिस इज द थिंग. अब इसमें क्या होता है कि एनिमेशन नहीं होता, तो इसलिए इसमें तो भाई अब आया तो कभी कभी आ जाता है एंड कभी कभी नहीं आता है. देखिए अभी अभी है तो अभी आ जाएगा. कैसे सॉफ्ट हैंड, व्हाट सॉफ्ट हैंड, इसके बाद एक मिनट देखिए. Okay, I am starting now, है ना, Romeo. So I am now playing the animation. Okay, see, this car is moving on a long highway. So therefore, compared to distance it travels, the size of the car can be treated as a small particle. Therefore, we can apply the kinematics of particles to this problem. Okay, next. Now, I will discuss about the how can we find out velocity and acceleration of a particle. If path of motion of a particle is known and one knows the position of the particle as a function of time, then the velocity of the particle can be easily calculated. Now, how do we calculate this? This was done during the Newton's time. Now, see, let us say that we have got a particle P. This particle goes into P dash in time delta t. I will play this animation here. This is the thing, this this animation. Let me Romeo, it is not coming. You have this. See, this is creating problem. I can see unless see either mouse should be given to me. See, देखो you are also not able to. Sometimes it comes, sometimes it doesn't come.
No, actually,
क्या? हाँ, मतलब you are showing me technique. I think there is a problem in pen also. देखें एक मिनट.
ज़्यादा मतलब पैसा देने का जरूरत नहीं है, स्लो ले.
नहीं, बट स्लोली में कोई दूसरी टेक्निक है. आई थिंक दैट हियर सी ये जैसे किया या एक मिनट या अच्छा 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 ओके 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 फाइन. चलो रोमियो विल गो देयर. नाउ आई एम playing one animation again. See, this is a part, this one, and this has gone to this one from in delta t time it has gone to p dash time. Of course, it has gone very fast. Animation should have been somewhat slow. Now here this distance pp dash is pp dash, this line will be basically delta r. It is a vector. It is the difference of two vectors. The vector, one vector is OP dash, this is O, this one point origin is O and this is P dash and this is OP. So, the difference between the two vectors RT plus delta t minus RT will be PP dash. PP dash is a vector, it is denoted by delta R. I will be always denoting the vectors by bold faced letters. In your notebook, probably you can put an arrow on the top of the alphabet to indicate that it is a vector. Now, arc pp dash is the total distance travelled by the particle and that is denoted by delta s. So, one has to understand the difference between a vector and this distance delta s. Delta s is not a vector, whereas delta r is a vector. Okay. Now, so velocity is the rate of change of the position of the particle. Calculus was invented in order to define velocity properly by Newton. In the XYZ reference system, if at time t the particle is at p with position vector rt and time t and at time t plus delta t the particle is at p dash with position vector rt plus delta t, then the velocity vector v will be defined as v will be limit delta t tends to 0, that means the time interval is very small. This is r t plus delta t minus r t divided by delta t. Now, r t plus delta t minus r t is nothing but the vector p p dash delta r. So, therefore, this is a vector and if I divide it by a scalar quantity delta t, entire thing is a vector. Therefore, the velocity is a vector only. Now, this is indicated in the language of calculus, this is called dr by dt, where d does not mean the product of d and r, it simply indicates a differential operator. So, you cannot cancel d and d here and say that it is equal to r by t, just like sin theta means does not mean sin into theta, it is basically symbol for the operator. Similarly, here d is basically one operator. This can also be written as dr by ds into ds by dt, where I have multiplied by a small change in the arc length and divided by the same quantity. This is basically a type of chain rule of derivatives. Now, next, in this figure delta r is the displacement given by the curved pp dash and delta s is this distance given by arc pp dash. In the limit, delta r divided by delta s becomes a unit vector tangent to the trajectory, because in the limit, if you know that time is very small and distance between p and p dash is very small, in that case this delta length curved will be equal to arc and therefore magnitude of delta r is same as delta s. Nevertheless, delta r is a vector and its direction is tangent to the direction of at the point p. If you find out the tangent at p, then this delta r is in the direction of the tangent. That is how we define the tangent also. So, therefore, Therefore, we can write velocity is equal to dr by dt. Same thing can be written as ds by dt into dr by ds. ds by dt can be called as speed. It is a scalar quantity, rate of change of the distance with respect to time, multiplied by unit tangent vector. Here cap et is a unit tangent vector. Therefore, velocity of a particle is a vector having a magnitude equal to the speed of a particle and direction tangent to the trajectory. That means path of the motion of the particle. Now, let me discuss the acceleration. The acceleration vector of a particle is basically the rate of change of the velocity vector. A is equal to dv by dt, which can also be written as d square r by dt square, where d square it is not any square, but rather it is indicating the double derivative. These symbols have been used. One must be very clear about that. D square r by dt square means the double derivative of position vector with respect to time. We can obtain A also in the following manner. We can write A is equal to dv by dt, again dv by ds into ds by dt. dv by ds by dt is nothing but the magnitude of the velocity, which is speed. So, this is the magnitude of the velocity into dv by ds. So, this is now since the velocity is a vector, therefore, it can be expressed in component forms also very easily. Vt is equal to drt by dt, rate of change of the position vector. R is basically xi plus yj plus zk, where unit vector I is along x axis, unit vector j is along y axis, unit vector k is along z axis. So, therefore, drt by dt is dx by dt I plus dy by dt j plus dz by dt k, which can be written as x dot t I, y dot t j, z dot t k. X dot t indicates that this component is a function of time. Similarly, the other component is also a function of time. Dot indicates the derivative with respect to time. Single dot will indicate first derivative, and two dots on the alphabet will indicate double derivative. Now, acceleration can be written as d square rt by dt square is equal to a. This is equal to x double dot t I plus y double dot t j plus z double dot t k, where double dot indicates the double differentiation with respect to time. Now, if the acceleration is given as a function of time, then velocity and displacements can be found by integration. Integration is the reverse process of differentiation. Now, example, suppose a particle moves in a straight line from rest with an acceleration of t, where t is the time. In 5 seconds, where will the particle be from the starting point? If this is the problem, then we can solve it like this. Here the motion is one dimensional, so we can do away with the vectors. In one dimension, only algebraic quantities are good enough. X can be positive or negative. It will not have, we need not give any directions. So, given A is equal to d square x by dt square, which is basically the x component of the vector, or if the motion is one dimensional, then the acceleration itself, that has been given as a time t. If we integrate it twice, we get x is equal to t cube by 6 plus at plus b, where a and b are the constants of integration. The constants of integrations can be found by putting the initial conditions. Since the particle starts from rest at the origin, therefore, at time t is equal to 0, x is equal to 0 and x dot equal to 0. Now, This gives A is equal to B is equal to 0, thus x is equal to t cube by 6. So we have found the position of the particle with respect to time by this formula. So with respect to the origin, at what distance is the particle, we can substitute the value of t, we can find out x. So for example, at t is equal to 5, x is equal to 125 by 6 units. In a SI system, it will be meter. Now, let us discuss the example of two-dimensional motion. We will study the motion of projectiles. Now, freely projected particles which move under the combined effect of a vertical and horizontal motion are called projectiles. It has only downward vertical acceleration due to gravity. On Earth's surface, the value of this gravitational acceleration is 9.81 meter per second square. So the motion of the projectile on the Earth's surface is of great interest. This finds application in the defense and in the space applications. Now following are some examples of a projectile motion. Now suppose we have got a missile. The missile is starting from one point, and see, this is the thing I am starting the animation. This is here I am starting. See, missile is going, and now it is reaching at the top, then it is falling down, and it has gone there. Play it again. This is starting. Okay, this is the thing. It is going, reaching at the top, maximum height, coming down again. If we know our target, then we must properly know at what velocity and what angle I should project the missile so that it properly falls on the target. Here a missile fired from one point reaches at the target at some distance away. Now another example, that if we see that this sloping surface, on this I am putting a ball. Now if the ball starts rolling down, if there was no gravity, then the motion of the ball would have been in a straight path. This is a gravity free path in which ball moves from this point and it goes up to this point. However, because there is gravity is present, therefore it will deviate from that straight path and ball will start moving downward. So therefore its path will not be straight, rather it will be forwarding in x direction, but at the same time it will come down in the y direction. Let us see this in animation. This is, yes, so this is the path of this one and it has fallen here. We can play the animation again. This is the, yeah, this is the thing, yes, play the start, yeah, see it is falling down. Okay, similarly this one. Now a basketball player is throwing a ball in the basket. He must know with what velocity and what angle he should throw the ball so that it falls into the basket. Of course, he does not do any calculations, he does not study the kinematics, but he does that mental calculation, and by that he is able to throw the ball. Now let me see this animation. It is going like this. It is the thing. Okay, we can, yes, we can play this animation again. Yes, yeah, this has fallen there. Now let me, so these are the examples of the projectile motion. Now we will discuss some terminology of the projectile motion. Now here this shows the trajectory of a projectile. One particle has started from point A and it has reached the another point. Now velocity of projection is the velocity with which the particle is projected. This is in meter per second. So suppose in this case u is the velocity of the projection. Then here the range of the particle is also shown. Range is the horizontal distance it travels. So, horizontal range, let me just okay, angle of projection. The angle between the direction of projection and horizontal direction is called as angle of projection alpha. Now, the trajectory is the path traced by the projectile. Here it is the trajectory, and this is okay. Generally it has parabolic shape. Then horizontal range, the horizontal distance through which the projectile travels in its flight is called the horizontal range. In this case, the range is this. Then time of flight, the time interval during which the projectile is in motion is called time of flight. Next, we will now study the case when the projectile flies over an inclined plane, because moving on the horizontal plane is a special case of moving on inclined plane. Horizontal plane is also an inclined plane with angle of inclination from horizontal equal to 0. So, a horizontal surface is a special case of an inclined plane. Let AB be a plane inclined at an angle beta to the horizontal as shown. Now a projectile is fired up the plane from point A with initial velocity u meter per second and angle alpha. This is actually angle alpha. This will be angle alpha. This is angle alpha. Actually, this is not A, this is alpha. Now, the range on an inclined plane AB and the time of flight are to be determined. If you want to find out the range, suppose I know the initial velocity u, that is velocity of projection, then I know the projection angle alpha, the angle which it makes from the horizontal surface. I also know the inclination angle beta. My task is to find out the time of flight and also the range AB. For that purpose, for the given projectile, we have to find out if we take the x axis along the inclined plane and y axis perpendicular to that. So, then we can study the motion in xy plane. Now, the acceleration is downward and that is of amount minus g, but it has the components along the plane and normal to the plane. Normal to the plane, the component of the acceleration ay, that is indicated by y double dot, is equal to minus g cos beta. Y double dot means d square y by dt square is the y component of the acceleration. Similarly, in the horizontal direction, ax is equal to x double dot is equal to minus g sin beta. If you square them, a square plus ax square will be equal to g square. Therefore, the magnitude of the acceleration is g only. Now, this one, so if we can integrate these both equations with respect to time, and we get the equation y dot, which is basically the velocity component in the vertical direction, that is equal to minus g cos beta into t plus a1, where capital A1 is a constant. Similarly, x dot is equal to minus g sin beta t plus a2, where a2 is another constant. Now, at time t is equal to 0, Vy, that is the vertical velocity y dot, is equal to u sin alpha minus beta, because this is the component which is normal to the plane, and the horizontal and the component along the plane will be Vx is equal to x dot, which is equal to u cos alpha minus beta. Therefore, if we put these values here, then we can get the values of the constants. We get a1 is equal to u sin alpha minus beta and a2 is equal to u cos alpha minus beta. Hence, x dot is equal to u cos alpha minus beta minus g sin beta, and y dot is equal to u sin alpha minus beta minus g cos beta into t. So these are the two equations in the form of the velocity components. Therefore, velocity as a function of time has been attained up to this point. Now, if we integrate both the above equation with respect to time, then we get x is equal to u cos alpha minus beta into t minus half g sin beta into t square plus c1. Similarly, y is equal to u sin alpha minus beta into t minus half g cos beta t square plus c2, where constants c1 and c2 are determined from the initial conditions. At time t is equal to 0, x is equal to y is equal to 0, because we are taking that as the origin. Hence, c1 and c2 both are 0. Therefore, thus the equation of the trajectory in parametric form is given as x is equal to u cos alpha minus beta t minus half g sin beta t square, and y is equal to u sin alpha minus beta t minus half g cos beta t square. Here x and y both are functions of t. So, t is the parameter knowing which I can find out x and y. Therefore, this form is called parametric form. Okay. Now, then after we have found, now after we found out the equations of this motion, now let me discuss the range on inclined plane. In this figure, AB is the range of the particle on inclined plane. It starts from A, reaches some distance here, again it falls back to B. So, we have to find distance AB with our coordinate system. We have to find x coordinate of point B when the y coordinate is 0, because at A and B at both the places y coordinate is 0. Now, therefore, if we put y is equal to 0 is equal to u sin alpha minus beta t minus half g cos beta t square, which gives two solutions, t is equal to 0 or t is equal to 2u sin alpha minus beta divided by g cos beta. That means the y component is 0 at the beginning at time t is equal to 0, and then later on at time 2u sin alpha minus beta divided by g cos beta. Therefore, this must be the time of flight. So, time of flight is given by 2u sin alpha minus beta g cos beta. In this, beta is the inclination of the plane. If it is horizontal surface, then beta will be 0 and time of flight will be 2u sin alpha divided by g. So, for horizontal plane, the time of flight is 2u sin alpha divided by g, which you have studied in your 12th class. Now, next, so now once we have found time t, we can put this expression in the expression for x, and then we get r is equal to u cos alpha minus beta into 2u sin alpha minus beta divided by g cos beta minus half g sin beta 4u square sin square alpha minus beta divided by g square cos square beta. So, we get this lengthy expression. Okay, let us see that if we can simplify this. This can be written as u square by g cos beta into sin 2 alpha minus beta. We know the formula for sin a, this 2a is equal to sin a, 2 sin a into cos a. then similarly the other part can be written minus u square g cos square beta 2 sin square alpha minus beta into sin beta. Here I can take sin alpha minus beta common, u square by g cos square beta common, then this will become cos alpha minus beta into cos beta minus sin beta into sin alpha minus beta. So, using some trigonometrical formula we try to simplify it, and this is equal to 2u square divided by g cos square beta into sin alpha minus beta into cos alpha. Now, this is the expression for the range. Now, so therefore, to repeat it again, time of flight is basically over when y is equal to 0 again. In the beginning y is equal to 0, when the particle has fallen down, then again the time of flight is 0. We have already found that t is equal to 0 or t is equal to this thing, hence the time of flight is 2u sin alpha minus beta divided by g cos beta. And the angle, now we are going to discuss the angle of projection which gives the maximum range. We have the expression for the range R, which is given by R is equal to 2u square g cos beta into sin alpha minus beta into cos alpha. Now, for a fixed beta, R will be maximum. If beta is fixed, that means the plane is fixed. So, therefore, sin alpha minus beta into cos alpha should be maximum. When sin alpha minus beta into cos alpha is maximum, then you get the maximum range. Sin alpha minus beta into cos alpha is basically half sin 2 alpha minus beta minus sin beta. Now, sin beta, beta is a fixed, this portion will be maximum when 2 alpha minus beta is equal to 90 degree or pi by 2 radian, because sin is maximum at an angle of pi by 2. So, 2 alpha minus beta is equal to pi by 2 or alpha is equal to pi by 4 plus beta by 2. So, therefore, this is the angle of projection when for getting the maximum range. If it is a horizontal surface, then beta will be 0, and therefore, the alpha will come out to be pi by 4. Therefore, on a horizontal surface, the angle of projection is kept 45 degree for getting the maximum range. If you fire something at an angle of 45 degree, then the range will be maximum. Okay. So, this is about the kinematics of a particle. Is basically, in a sense, in kinematics of a particle, you need to carry out vector calculus. If you are given the displacement as vector, then you can differentiate it and apply vector calculus. You can find out the velocity and acceleration of the particle. Also, if somebody has given you acceleration as a function of time, then you can integrate and you can find out the velocity and you can find out the displacements also. Now, let me see number of problems you can solve. For example, suppose somebody gives you acceleration of a particle is a vector, a is equal to 3t I is a unit vector, minus 2t square j plus 5t cube k meter per second square. Okay. If we say particle starts with 0 velocity at the origin, we write that condition that x dot at 0 is equal to 0, x is 0 at 0, therefore, if somebody wants to find out particles position, displacement, distance travelled after 5 seconds, then we can integrate this expression and find out the particles position. We can find out the particles position, displacement and distance. Suppose somebody wants to find out the distance travelled, then of course we know that a small distance ds will be equal to dx square plus dy square plus dt square. Therefore, dt square, this is the thing. Therefore, what happens that if you want to, so between two time limits, now dx can be expressed in terms of dt, you will be getting some expression for x which will come in the form of dt. Then you have to integrate between 0 to t this quantity dx square plus dy square plus dt square, which will basically come dz square. This is dz square which will come in the form of dt. So, then you will be able to find out the distance travelled also. You can find out velocity, you can find out speed and acceleration. So, this is what that this one. Another problem can be of this type, that here if you have this is a slider crank mechanism, this is a crank, then this is a connecting rod and this is a slider which is moving. Now, you want to find out the velocity and acceleration of a slider crank mechanism as a function of theta. That can be easily done provided we can express, we will be knowing the crank radius r and we will be knowing this length as connecting rod length L. Then we can find out the distance of this point, this particle which is in the slider from the origin as a function of r and as a function of theta, and finally we can differentiate this expression to find out the velocity also as a function of theta. Velocity will contain the term of d theta by dt, which is nothing but the angular velocity of the link. Similarly, there you can solve the problems of the projectiles. Now, here this is, for example, this is the thing, projectile. Now, if it is, this is 30 degree, it is fired at say 45 degree from the horizontal, this is the, then you know how it falls, what is the range. These type of problems you can solve. Similarly, there may be problem of this type. Now, if you, there are two columns, this is this one and this is column B, this is B and this is D, A, B, C, D. Now, suppose you fire some shot from here, now at what angle it should be projected so that it hits here, what should be the angle of projection. Naturally, if you will hit along this line, it will not touch D. So, therefore, we have to decide the angle of projection. So, the similar type of problems can be solved. Now, in my next lecture, I will be talking about kinematics of a particle moving on a curve, that the particle is constrained to move on a particular curve, then how we study the kinematics. For example, in this case, the slider is constrained to move in this guide way. See this slider, it is not free to move anywhere, it is just constrained to move. This is a straight surface, but sometimes the slider may be constrained to move on a curved surface also. So, these type of things also we will be studying that in the next lecture.